Hello guys, I found these 2D drawings for certain shift method which we can try to draft them. And the first thing we need to do is to understand these 2D drawings. And it is obvious this one is a top view. And when you view from this side, this is what you see. That's obvious. And when you view from this side here, this is what you see. Meaning we have this here, this one here is a flag. This one here, you can see a flag, yeah, that is on both left and right side, because when you view from this direction you see two of them, and when you view from this side you see the same flag, and the length of this flag is 4 and by 1.5 here. Therefore, we need to draw this top section first. That is a planar on top view, top plane, and use center rectangle here and dimension here. We saw this one is a 10 by 7.5. I'm using sheet metal. Then I need some center line here, and the one here. I need a corner rectangle like that. I want this corner rectangle to be symmetry. Let me first dimension this. Yeah, it is 7 by 10. That's fine. Then yeah, you see that symbol? It means left and right is symmetry. Same case, another one here until I see the same symbol here like that. Then I want some equality, this edge and this edge to be equal, and I want to delete this segment. Oops. How to delete? Let me first for dimension on this one here. If you select dimension, this we have said this one is let me first for zoom here, dimension now, this to be 1.5, and we said if you select equality, this and this to be equal. Therefore this one also is we saw this one is a 4, dimension this to be 4, and now delete segment. Fine, 4. Okay, fine. We can use default thickness. Then we said if you view from this direction, this is what you see. Therefore we need a flat on this side. Therefore if you zoom in here, I need a flat here on this edge. Let's now model this profile 2.5 by 4 by 1.5. Therefore we can see height is 2.5 here. Let's see the height, 2.5. And if you go to sketch, let's go normal. For the flat, you can be able to sketch the actual shape of the edge of the flag. Therefore, we have a line here like that. Dimension from this point to this point here to be 1.5. This from here to this point here to be 4, and we don't need this. That's all we need to do. Go back front view, not front view, left view, so that you can see the bed radius. Is bed radius defined? Let me see. That is defined somewhere. Yeah, 0.5. This defined as 0.5 here, 0.5, and say okay. You can see we have our flat, and we can now mirror this flat to the front like that. If I view from top, if I view from front, yeah, you can see. Let's view from this side. Yeah. Next is, this is what you see when you view from this what you see. We know how to define this flange. These are the dimensions. You can see 0.75, 0.75, and 1.75. Let's now define those. For that, you don't need a flat, we need a flange on the top edge. And we know to define the shape, to sketch the shape, sketch, go normal. Yeah. And just notice this, the difference between flat is the surface, you are defining the shape of that surface, but for the flange is the profile. Therefore, this, I don't need this one here. I can go like that, and I need another line here. And you have seen from this point to this one here is what they are saying, what we have on horizontal, delete this, is 0.75. Another one from here to here is, what's this, what, delete this. I want to define, let me first of all delete this section here. I want to define dimension from this point to this one here to be, what are these now, delete, to be 0.75. These are the automatic dimensions that are being formed. So from here to here to be 1.75. Let me double check. Yeah, 1.75. Yeah, that's fine. And you can say okay. Same case to the bed radius. Let me see the bed radius. Not defined. Yeah, not defined. Okay, that's fine. Let me first of all do some cleanup here. Yeah, not defined. Let's use default thickness like that. Then you can select, let me see the data planes, the right one, flange, mirror to the right plane. Okay, then hide it. Yeah, let's see all the views. Back view, this is the view, that is this view. You see this view, it is this view. Let's go to the next bottom view. Let's go top view. Top is this, but now this one is rotated. Let's go to the other view, right view. You see this view, it is this view here. You can see this one here. And next is some round. You can see we have a 0.5 round. Yeah, 0.5 round. Let me put some round here. Therefore, go to engineering, round 0.5, select. For the sets here, select this edge. In fact, okay, let me start. I wanted to select on the mother one, but it is fine to save some time. The one before you do the mirror command, sometimes this zooms a lot. let me I don't understand why sometimes my model doesn't zoom as I want. Therefore, that is okay. I can work around. Control D for isometric. Then I need this one here. Then come here, that edge. Oh, okay. Also, I need this edge. Come here, that edge, and this edge here. Okay. This is the round. Next, I can see we have some cutouts here. They are 1.75 and they are 1, 2, 3, 4, 5, 6, 6 and 0.63. Therefore, for us now to make those cutouts, we need to embed. We need to embed. Okay. Then I need to sketch on this one here. But instead of saying sketch, I like going to the sheet method and select extruded cut on this face here. Yeah. Therefore, you go normal. We need a center line here, center line here. Then I need a circle here. This one's supposed to be a radius value of 0.63 and let me see 0.75 1.75 from here to here 1.75 dimension from this point to this point here 1.75 divided by 2. Also the same case here 1.75 divided by 2 and say okay. Then I need not to pattern this. Let's click here, select pattern. For the type, I'm going to use fill. I want everything to be to fill. The reference define this face here, sketch. I want to use the fill. Sorry for that. I need to select this, define. This face here, sketch. When using fill, you need to define the boundary. Therefore, first of all, you select this to be your references, edges, and say close. Then select corner rectangle like that. Then you need this one to be coincident like that, coincident like that, like that, like that. If you say okay, you see now what happens. We have to define spacing. That was 1.75 and you have to deselect. If you say okay here, you see how it makes the cuts. This is not what we want. Let me edit here, go normal. Let me see. Okay, I can't see go normal. You can deselect what you don't need. I don't need this. I don't need this. Same case applies. This for not needed. Like that. You can see now. Same case, we can apply these holes of 0.35 by 0.5. Same case applies. Extrude cut on this face. Normal. I need a hole here. 0.35 and from the center from the center of here, dimensioning from the center to this point here, this 0.5. Okay, I can now easily say, okay, I can now pattern this. If you select pattern, for the type I want to use point, and for the references I want to define this here and sketch and select point, a point here, another point here. Let me see, these holes are, you can see here, they are, for this around in these holes, they look concentric, but we can still define, their exact position, because yeah, this one is 0.35. If I was to define, let me see, okay, let's delete this. Yeah, they are not, because it's 0.35, they are not concentric. Therefore, let me delete this relation here and dimension from this point here to this to be 0.35. I'm just checking here. This is 0.35 and the height is 1.25. Therefore, the height is 1.25 from this one to the hole, 1.25 from the flat. Okay, this one here is 1.25. This one here, last dimension from this point to this point here, 0.35. And we can now have our center line, and we can now select this point, press Ctrl this point, mirror on this line to get them the other side. Again, another center line here. Let me activate this one here, because I want a center line here like that. Then deactivate them. Again, I want to select this point, mirror to this line. Oops, let me see what's happening here. Okay, I want this point to be mirrored onto this line. Let me just insert my point to save my time. Then I can dimension this point from this to this as 0.35, and I'm done. You can see the holes are there. You can use a point pattern to save some time. Then you can bed back. You can see you can bed back. Okay, that's how my component looks like as per the 2D drawings. You can see the top view. Let's go to the top view and see top. You can see the top are similar to this. Back view, you can see it is similar to this. Then front view, at its left view is the bottom one here. Okay, that's how you can model that part in Creo Parametric. If you want to view an appearance here, maybe you can use this, go to geometry, go to body, this apply appearance, go to body, this apply. Yeah, that's how you can model that sheet metal part in Creo Parametric. Thank you and stay tuned for more.